Hello, this time I've got questions from optics which have been taken from the past year papers starting from 2017 until 2020. So here is our first question. The point labeled F are the principal foci of a lens. A beam of parallel light is incident on the lens. Which diagram shows the path of the light after it passes through the lens? So as you can see, this is the convex lens, and we will just remember the rules. And the rule here can be stated as if a ray of light is parallel to the principal axis, after refraction through the lens, it passes through the focus. So in this case, it's not passing through the focus. Here also, it's not passing through the focus. Down there, it cannot reflect back. So we have the correct option as option number 2. The incomplete ray diagram shows two rays of light that have passed from one point on an object through a thin converging lens. So this is the convex lens, this is the object, and the two rays have been shown. Which type of image is formed and on which side of the lens is it formed? So in this case, we see that the two rays, they are not meeting each other. What we do is we extend them backwards in a straight line to see where they actually meet. So they're meeting somewhere here, and this is where the image can be formed. This is the place where the image should be formed. Now, looking at the options, it is not going to be real image, it's virtual image, and it's on the left side. So we have the correct option as C. Question number 3. The diagram shows an object O in front of a thin lens that is convergent. At which point will the lens form a sharp image of the object? So we will try to figure out where the image is to be formed. This is the position of the object. This is the ray of light which is parallel to the principal axis, and it should pass through the focus, that means passes through B. Another one, if it passes through the optical center, that's the rule, it goes undeviated and it goes this way. Wherever these two meet, the image will be formed, and in this case the image is formed at D, so the correct option is D. Question number 4. An object is placed before a plane mirror as shown. Student views the image of the object in the mirror from point P. Where does she see the image? So here also we will apply certain rules for the image formation. So from this object, if we have this as the incident ray, then we can draw the normal, and the reflected ray would be at the same angle somewhere here. Now this can be produced backwards. We can take one more position somewhere here, or can be in the straight line, it goes straight, so this is where it is formed. Also keeping in mind that whatever is the distance of the object from the plane mirror, the distance of image is also the same, so the image will be formed at D. Question number 5. A thin converging lens has a focal length of 6 cm. Observer looks through the lens at an object which is placed 4 cm from the lens. So in our case, the object is before the focus. That means it is placed between the optical center and the focus. For such cases, the image is always magnified and it is virtual. So it would be formed on this side and it would be magnified. The correct option is enlarged and virtual. Question number 6. Which diagram shows how the light from the candle is reflected by a mirror and shows the position of the image formed. So in this case, you have the object as a candle and the image should be at the same distance. But how the rays are being incident and reflected. So in our case, if we see all the four diagrams, D cannot be because the image should be in line of the object. So C and D can be eliminated. Out of A and B, the incident ray and then the normal, and this should be the reflected ray. In this case, it is incident and going back straight to the eye. That is not the case. So option A is the correct answer. Seventh question, the diagram shows a ray of light incident on the surface of a rectangular glass block at 90° to the surface. This is the glass block, this is the ray of light. Which quantities remain unchanged as the light enters the glass block? Since it is incident normally, direction will not change. So that is one case. Speed always changes when light enters from one medium to another. So speed will change. So out of these, direction obviously does not change. So direction and frequency also doesn't change because of the same source. So A is the correct option.